Good afternoon, everyone, and welcome to breakout session AIM333. Today, we are going to be talking about how Taco Bell is using machine learning-based forecasting to improve digital availability using Amazon Forecast. My name is Brandon Nair, and I am a senior product manager on Amazon Forecast, which is a fully managed AWS machine learning service that puts highly accurate demand forecasts into the hands of developers and enterprises with few to no lines of code required. With me, I have my colleague Charles Laughlin, who is a principal AI ML specialist at AWS, as well as Niraj Revankar, who is a director of data and analytics at Taco Bell. And he's here to talk about his experience of using Amazon Forecast to derive business value at Taco Bell. In terms of the agenda, I will start us off by providing an introduction into Amazon Forecast as a fully managed service. I will talk through our core competencies, as well as some of our marquee features. Then I will hand over to Niraj, who will go through his experience of how his team used Amazon Forecast to increase digital availability at Taco Bell. We will then hand over to Charles, who will walk us through how Amazon Forecast is purpose-built to reduce your time to market. And he will close off the presentation by providing you some resources on how to get started on using Amazon Forecast service. Amazon Forecast centers itself around the science of using previous historical data in order to predict future values. Now, generating demand forecasts is a key business input into a broad range of industries and use cases that span from inventory planning to supply chain optimization to financial planning to energy demand planning to even forecasting workforce planning requirements. And that list goes on. At Amazon Forecast, we make it easy to obtain accurate ML-based forecasting models that are approximately 50% more accurate than your traditional statistical forecasting models. And we make it easy to deploy these models into production. Amazon Forecast is built on the AWS ML stack. Now, you're able to build machine learning models at any level of the AWS ML stack. However, the bottom two layers, which are the ML services and the infrastructure and frameworks layer, tend to be geared toward those users that are more akin to technical expert machine learning practitioners, or those that want to invest the time to build and deploy these models from the ground up and manage their own infrastructure. Amazon Forecast sits at the top of the ML stack. What this means is that we're able to bucketize all the capabilities of the ML stack into a service that allows users to access accurate machine learning models without the need to be an ML expert. And as a fully managed service, Amazon Forecast derives value for our business customers in one, you don't have to be a technical expert in order to reap the benefits of ML-based forecasting. And two, you don't have to invest the time and the resources to write out all the code to train, build, test, deploy these models by yourselves. And that saves you time to market. Later in our discussion, Charles will take us through exactly how Amazon Forecast is able to save you much time to market. Users of Amazon Forecast are able to access it either directly through API calls or through the AWS Management Console. And to use the service, users will bring in data in the form of historical data, which represents their demand forecasts that they are trying to predict for, and optionally related data such as price and item metadata such as brand name, which can be very important in improving the accuracy of a machine learning model. Once the data has been imported, Amazon Forecast takes care of the processes to build out these models and deploy them at scale. Let's dive a little bit deeper into the Amazon Forecast service. Amazon Forecast focuses on driving business value for our customers by targeting 3 pillars. The first is to simplify and automate the process to obtain accurate ML forecasting models. The second is to provide capabilities that allow you to deploy to operation these models, as well as manage them when they are in operation. And the third is to provide tools that allow you to derive business insights from your forecasting models so that you're actually able to make business decisions. I will go through each of these pillars in detail. So the very first pillar is focused on simplifying that process to build a machine learning model. And that process really starts with your source data. Now, I'm sure many of you in the audience will empathize with this, but source data needs to be cleaned, and it needs to be shaped appropriately for you to build an accurate machine learning model. And let's face it, source data has pitfalls. You can run into source data that has missing values, for example. Amazon Forecast provides a feature that allows you to handle such a scenario where a user can define an imputation strategy of how to fill in and take care of those missing values. For example, you can fill it in by using the mean or the median of your data sets. We've also heard from customers that their data sets or their demand forecasts are sometimes also impacted by external factors where their source data does not take that into account. For example, the timing of holidays. That's when companies go through ebbs and flows in their forecasts. With Amazon Forecast, you're able to enrich your source data by adding in data from holidays as well as weather to create a training data set to obtain a more accurate machine learning model. Once your data has been treated, Amazon Forecast takes care of the featureization, and then it moves over into the ML build process. At this stage, customers have the benefit of using an Amazon Forecast AutoML called AutoPredictor. An AutoPredictor uses ensembling strategy in order to create a more accurate model. When you call an AutoPredictor API to train a model, it will provision up to 20 clusters, including neural network algorithms. It conducts the hyperparameter optimization automatically, and it goes through an ensemble routine in order to obtain a blended ensemble model across 6 different algorithms in order to produce a model that has the least error rate. And using AutoPredictor, users are able to obtain a forecasting model that is 40% more accurate. Once your forecasting model is trained, we also provide you with error metrics and explainability data so that you are able to better understand exactly how your time series data is influencing your forecast. Amazon Forecast also provides you with capabilities that allow you to operationalize and maintain your models in production. With Amazon Forecast, you're able to host your models, you're able to compute inferences on a schedule, and we provide you with features such as Model Monitor. Model Monitor solves the problem of allowing you to track the performance of your model or the accuracy of your model over time. And the end goal of that exercise would be to identify when there's degradation in the accuracy. This can frequently occur when the data that was used to train your original model is no longer representative of your business in its current state. When you do identify that there is such a degradation, you're able to use Amazon Forecast to retrain your model so that you always have an accurate model that is reflective of your business. The output of Amazon Forecast is an S3 file that contains your forecasts along with the quantiles that you specify. And with it being in CSV format, the free-flowing nature allows you to really plug into your existing data pipelines and your existing systems with minimal changes required to those systems. Later in our discussion, Niraj will talk us through how his team was able to use Amazon Forecast and CloudFormation templates in order to integrate into their existing systems at Taco Bell. The third pillar that we focus on is on deriving business insights. And here we are primarily focusing on a new feature called what-if analysis. We frequently hear from our customers that they are looking for ways to better understand their business drivers and how that impacts forecasts so that they are able to make decisions to appropriately optimize their businesses. For example, in retail, a typical scenario is when a retailer is conducting promotion planning. And a question a retailer may ask is, across, say, 1,000 SKUs, what is the optimal price point across these 1,000 SKUs that maximize the demand of a particular store? What-if analysis is geared to answer that very same question. Using what-if analysis with Amazon Forecast, you're able to transform your future data. For example, you're able to reduce the price by 15%. And with your already trained ensemble model that has learned the relationships between your products, as well as the characteristics that drive your forecast trends, you're able to predict a new scenario, a new forecast under this new scenario with a lower price point. At that stage, you're able to compare your forecasts between your base scenario and your new scenario and identify which is better for your particular business scenario. And today, I'm happy to announce a new feature that we launched just 2 weeks ago. This feature allows customers to forecast for cold start products up to 45% more accurately than before. Cold start forecasting is an age-old problem. How do you create a forecast when you don't have any historical data to make that forecast? This frequently happens in industries where you see a constant product turnover, such as in CPG or retail or manufacturing. And it typically occurs when companies are bringing net new products onto the market for the very first time, or bringing in brands and catalogs that may exist in the market but have never been sold by that business, or even expanding product lines into new territories. In each of these cases, there is no historical data in order to establish your forecast. And so when you look at traditional statistical forecasting models, such as ARIMA and ETS, they fall short because these models need historical data in order to establish the parameters that allow you to make a forecast. And here's where neural networks really play a key role. At Amazon Forecast, we are employing a novel technique that looks at the item metadata within your data set to identify those products that are most closely related to the cold start product that you are trying to forecast for. With the neural networks already establishing relationships between your products, we're able to use those specific products to impute a forecast and ultimately create your cold start forecast. And I'm happy to say that this product is fully GA in all regions supported by Amazon Forecast. Amazon Forecast already caters to a wealth of customers, and that spans both industries and use cases, be it retail use cases, for example, with more retail, or workforce planning with Fornamics, or travel and hospitality with affordable tours. We are able to create forecasting solutions that meet each of these different use cases. And I'm looking forward to a discussion later where I could learn a bit more about your interest in forecast and the use cases that you are looking to support. But for now, I will hand it over to Niraj, who will walk us through his experience of using Amazon Forecast. Green is good.
Green. Thanks, Brandon. It was a great overview of the Forecast product. And what I took up from there is companies like us that have gathered so much data, the vertical focus of Amazon and providing some of those tools and helping like us to bring our own data and then tie in these services to get better time to market is pretty exciting. And I think data is core to what we do, and I'll share a little bit, but getting that quicker into the hands of the customers and getting the business value is what I'm most excited about. Hey guys, thanks all for joining the session. My name is Niraj Revankar, and I'm a director for data and analytics at Taco Bell. And I'm responsible for the data engineering, business intelligence, data science, and reliability services. And really have two main objectives. One is make sure that we have superior customer experiences that's powered by data. And the second one is making it easier for our team members that are in the restaurants and making it easier for them to serve the customers. A little bit about Taco Bell, but just by show of hands, how many of you have actually been to a Taco Bell? That's what I was expecting. We've got it's a funny story, just the number of folks that have, we looked at the population of the US and the folks that have actually been to Taco Bell once. It's a pretty large population. So how many of you actually used an app or a delivery service to get your food, Taco Bell food? Sounds about right. A lot of what's interesting, like when I looked at it, is delivery for QSR was an interesting concept for me. But what we're seeing is that, yes, folks are really gravitating towards using digital, and it's an important one for us. I think it's an important channel. We do 1 billion plus orders per year, so that's an incredible number. So that's a lot of tacos. And one thing I heard, we deliver like an average delivery, order to delivery is less than 4 minutes. So if you start to think about the number of restaurants, the number of tacos that we sell in a record amount of time, it's hugely efficient. So yeah, it's a pretty exciting. And data is playing a great part, and talk a little bit about that. The tech at Taco Bell, we're undergoing a digital transformation for our technology, right? So if you think about a few years ago, you had a couple of channels. You went through the drive-through, the front counter to order your products. But with the expansion in digital channels, we're seeing app, we have the kiosk, looked at delivery, so the touch points have increased. And as you can imagine, there is a level of complexity that comes with it. And how you integrate all those orders, you gotta make sure that the order's hitting the kitchen, that the food is prepared, and it's fresh for you guys to pick up. So with a lot of this, I think the key piece that I'm excited about is the fact that a lot of these are connected, part of our connected restaurant strategy. And what that means is that each of these systems push the data to cloud. And that's where I come in, where I can then take all that data, connect it, curate it, and make it available for consumption. So as we started to think about what we want to do with it, I think as we get into the Amazon Forecast and all the AI ML services, I think it's key for us to think about what was the data strategy, right? We said, hey, look, let me take a step back and say, okay, well, there's a lot of stuff you can do with it, but we need to make sure that our architecture, our data strategy is first fully bolted on, right? It's not something that's an afterthought. So data is sitting at the table with the technology leaders to determine, okay, what are we gonna do with all this data that's coming out? Amazon provides the tech stack and the range of services for us to be able to do that. So we said, hey, look, we need a strategy, a lakehouse strategy to make sure that we've got multiple integration patterns, whether it's batch-based, whether it's event-based, whether it's real-time, ability to store it, ability to then connect all that data, create offline decision models, and then make it available for an event, and we'll talk a little bit about that. The other piece is it's not just the restaurant data that we're talking about. We also have all of the MarTech or the customer data. As our digital footprint grows, the number of customers grow, folks that want us to interact with them and opt in to email communications, we want to be able to make sure that we give them superior customer experiences. So you start to think about that, and they call us. They call us like, there's bad food. Hopefully you guys have had, instances where your food wasn't as fresh as you thought it would be. Making sure that we capture that information and then circle back with you with offers or recovery processes is another key piece. So putting all that together into our data architecture was a key step, and we've been doing this for about a year and a half. We've collected a lot of data, right? And we've collected a lot of data, and now we've got our data scientists that are working on this. But there's a lot of questions that come up. And what happened this year was, as we were looking at digital channels, we saw that, yes, our digital channel growth is high. During COVID, I think that's when I started to actually install QSR apps, because I wanted contactless pickup. I thought after COVID, it was going to go down. What we are finding is that behavior is here to stay. I think it's the convenience factor. So we want to win in digital, and a key piece of this is how do we make sure that it's available, the channels are online and the channels are available. And I'll talk a little bit about why that's important. So when you have we have our own channels, which is our e-commerce and our kiosk, right? We consider them our own channels. When you place an order, we have IoT-based alerting systems to tell us if things go down, so we can take an action. But when you are working with a third-party delivery, when you place an order on DoorDash, it goes to the app. There's an API integration with our POS and the kitchen system. We need to be able to then say, okay, when is the driver going to be dispatched so that we can make the food fresh and hand it over to the driver? So there's a lot of complexity. There's a lot of integrations that happen. But with any technology, one of the things that kind of drives some of these is algorithms. Now, if for some reason there's an integration point where it breaks down, let's say it doesn't go to the kitchen or the POS, and that could happen, how do you then recover from that? Because if you have too many cancellations, if you're a DoorDash app, you're going to say, okay, well, it's bad customer experience. So they're going to shut it down. And they have algorithms to say that, right, after a certain point, we're going to shut down the store. Now, the challenge is that we have to manually enable that store for DoorDash. So if you went into the app and you say, hey, look, why don't I see this restaurant on my app? The reason is it's got disabled and nobody enabled it. And we're working on trying to make that an automated process as well. But it does require human identification and intervention to bring the store online. So what came to our team was like, hey, how do I make sure that we know whether a store is online or offline? And how do I use data science to then get ahead of that issue? So the objectives were improving the stakeholder visibility to that, right? So I have a franchisee, I have 100 stores. I want to make sure that I know whether a store is online or offline. We could do that with all of our data because it was prior day. We could say, hey, look, you didn't have a transaction yesterday. Maybe there's a problem. Go fix it. And a lot of times that improved it considerably. But we want to take it to the next level where we can do this in real time. And where I think this all comes together is now we've got our POS systems that are real time transmitting the data to cloud. We've got an offline decision system that we worked with the Amazon Forecast team to kind of build the model. Now we can start to connect and say, hey, look, within a few hours, we can determine whether or not the DoorDash may be off, or the channel may be off. So I think the key aspect there is optimization, right? As we start to think about, there's things that we could do with data and analytics, but then how do we optimize it? And that was one of the key objectives. And keep in mind, so if you think about billion transactions, a big portion of that is digital, a high number of that is delivery. And even if we fix a certain amount, it equates to almost adding a few hundred stores, virtual stores, to the Taco Bell system, because if you think about our size, which is why this was such an important business problem to solve. So what we did was, now we had the data. As most of you in the organization know, you've got a plan. You've got data scientist teams that are working on key projects. In our case, cook schedules, making sure we order the right inventory, all of that stuff, that's important, right? And when this issue came up to my team, we were like, OK, well, how do I continue to optimize? This is where we partnered with Charles and team, which is what I'm most excited about. I said, hey, look, we've got all this data. We want to turn around and look at, what does this mean from a business standpoint? So we got the next-gen POS data. We got the offline decision model that Amazon built. And we used a lot of the AWS services then to say, OK, well, let me send you an email within an hour where we say there's a problem. Because there's a lot of false positives. Because keep in mind that a delivery order is kind of sparsely populated, right? You're not going to have delivery orders throughout the day. There are day parts, lunch, or maybe late night or evenings where you can have more delivery orders than the others. So we wanted something that's accurate enough at a store level that kind of tells us that information, which is what we did with the Amazon forecast. And we got that. We ran the POS, the real-time POS that was coming in. And then within a couple of hours, if there was something like we expected during a day part for this particular store, high delivery store, for example, we started to send emails to those stores, right, internally. We wanted to try to track like what's happening. And that was really, so from a prior day, like you had to wait for a day previously to know whether or not your store was offline. Now within a couple of hours, the stores knew that there's some problem. And as we kind of improve this, the forecasting capabilities, we're getting real-time store hours information to make sure the store was not really closed at that point. And it was really, truly an aggregator issue. The ability to tweak that, right? An ability to bring that all together, send an email is very powerful. So one of the things our community likes, the franchisee community, is like they don't want to go to a report and find out if something's an issue, right? It needs to be on your phone. It needs to be a text message. It needs to be something actionable. And if you look at this, there's a lot of things behind it. We were able to do that in, I think, a little over 4 weeks. And to be able to get to that speed and impact and make an impact to business, I think was, to my mind, one of the biggest outcomes. So I think Charles is going to go into details on how this whole thing works. But really excited, and thanks for your partnership, Charles. I think it was a fantastic effort of us bringing the data and you guys bringing your expertise. So I'll hand it over to you. Thank you.
Thank you, Neeraj. Thank you for being here with us today. It was really a high honor to work with you and your team. When we had our first call with Neeraj and his team at Taco Bell, they had a very clear mission on something that they wanted to accomplish, a change that they wanted to instrument in their business. And they were also very dedicated in making that happen quickly. And we weren't racing. But as it turns out, in 2.5 weeks, we had 2 production forecast operations working, all fully automatic. And then they bolted onto that later on, the messaging that Neeraj described. So I need to go forward to the next slide. I was focused on the audio working. So time to market is really important for companies that want to optimize. You want to start creating better business value. You want to start serving your customers better. And the thing is, you don't want to wait quarters for that to happen. You don't want perhaps even months or weeks for that to happen. So I think Neeraj's story has showed that is evidence that it is possible to make a change quickly in an organization, even in a large organization like Taco Bell. And the reason that we're able to make things happen in quick time to market are based on 2 dimensions. The first dimension is the Amazon forecast service itself. And Brandon articulated some of these details earlier, handling all the phases of the ML lifecycle, from data preparation in the beginning to splitting the data. But really, one of the hallmarks here is in the science and the R&D that comes from having multiple machine learning models. because the reality is that the demand patterns across time series differ. Some are volatile, so there's more history on others. Some have more seasonality. So it's very unlikely that one model is going to fit best all the time series. And then finally, the service is able to handle the infrastructure management. So from a developer perspective or from an expert ML perspective, no matter where you are on the spectrum in terms of persona, when you want to build a model, you simply make an API call. And we'll look at that here. And when you make the API call, underneath the scene, Amazon Forecast is already looking at descriptive statistics to understand the size of the data and the distribution of the data. And it spins up a cluster that's properly sized to accommodate your data. So that decision point about, did I build a cluster too large and wasteful in resources, or was the cluster too small and run out of memory? That decisioning now is made automatic. In the first cluster, I think Brandon mentioned we can launch as many as 20 of these to do experimentation, lots of kinds of models. But the first one here, maybe that's an ARIMA model or a statistical model. And then we'll have also convolutional neural network models with different hyperparameter optimization and different backtesting windows. But the thing is that Amazon Forecast Service orchestrates all of these, spinning up the clusters, waiting for them to complete. There's obviously backtesting data in each of the clusters, so we know accuracy metrics on every individual time series. And then there's an ensembling phase. So for every single time series in the data set, in this hypothetical case, with item and location, for example, item number 1 might be in a statistical model. Item number 2 might be beneficial from a neural network model. And then item 3 might be a 50-50 blend of the two. But the idea is that after ensembling, there's a unique recipe created for every single time series. In the Taco Bell case, that would be by store, by day part, by hour, and then by delivery channel, just as an example. And then that model itself is saved as a graph artifact that can then be called for inference. So normally, instead of having to go through and spend weeks and weeks and iterate and do hyperparameter tuning and building, which is sometimes common, Amazon Forecast is making all of this possible generally in about a day. So in the case with Taco Bell, we did complete that cycle in 2.5 weeks, but they were able to do a POC within, I think, just a day, and the statistics were there, and then the team had to go back and they were able to look at it. But that does mean at the end of a couple of days there was some stats, without having to go through and build all the models and all the infrastructure management. So continuing on, in addition to Amazon Forecast, there are some other complementary AWS services that make this possible. One of them is in CloudFormation. So think of CloudFormation as an infrastructure service that provides repeatable CloudFormation templates, and that way there's consistency with the deployment. So I've got a QR code that we'll be sharing with you for a GitHub site. It provides a YAML file, and this is what Taco Bell used to spin up all the cloud infrastructure to support the workflow. It'll do things like create S3 buckets and create reliable and consistent permissions. And one of the next items I'll be talking about is step functions. And if you saw Dr. Vogel's today on this, he talked about synchronous calls and about orchestration with step functions and event bridge. So here we're looking at the importance of using step functions to orchestrate. So CloudFormation did the deployment, and then the orchestration here from execution to execution happens with step functions. So for example, step functions are able to do things like have a process that goes from A to B, as shown here. So importing data to Amazon Forecast. That's an API call. And what happens is underneath, there's a cluster provision to import data from S3 into Amazon Forecast. And that is a synchronous call, an asynchronous call. So while that process is running, the step functions are then monitoring the process to see when the import is completed. And then only after the import is completed, then it moves forward to creating the model. And that's the slide that we just looked at, where you see the clusters being built for training and so forth. So when the CloudFormation template is deployed, one of the things it's doing is creating those step functions. And the step functions also have a workflow built for them. And we looked at the lake formation, as Neeraj mentioned with Taco Bell, their data resided in S3 data lake. So in terms of orchestrating the workflow from end to end, and again, this is part of the quick time to market, The first part that is already delivered there, and this is available in our GitHub site, is the Athena connector. So what that means is you put in your metadata, you put in the SQL statement, and that'll go get your historical data where that resides at rest. And it can be in different heterogeneous databases. And this is the thing like the historical demand and item metadata and others. And when those queries complete, that lands this data set out on S3 as different objects. So this is used for model training, but it's also used to produce model inference. Next along this workflow with the step functions is the import process. And so the way this works is the step function will start. As soon as the Athena connector completes, the import begins without any delays. It's all serverless, and you don't have to worry about building servers that are going to manage and sleep and wait and so forth. And that will start the process to import data into Amazon Forecast. And that process may take minutes to longer depending on the size of the data. But when it's completed, the next part is it will signal that's completed and then start the process to build the predictor. So think about this as that trained ML model. And the predictor itself, this is the part where it's going to spin up the clusters, as many as 20 of them. And the predictor training can take minutes to hours to several hours, depending on the size and scale of the data. And that may be, again, so think of that as a long-running process. But what the step function is going to do is monitor that for completion. And when it is completed, it's also going to export the data from that predictor to S3. What that means is you'll have time series statistics available on S3 and be able to look at the spread of accuracy across different time series. That's also going to produce a saved model. And that saved model is used next when the Amazon Forecast hits the next step function, which is going to produce the predictions. So it's at this point that the API call is going to be made, and it's going to take the data that's been imported, and it's going to pull it through the saved model, the named model, the graph that's existing, to produce future predictions. And then the future predictions are going to land on S3. They're simple CSV files. They can also be Parquet files. So this is going to be at the item level by time step, and also for the different quantiles you choose as a business. And most of our customers want to take that data and then orchestrate it and deliver it to many different target systems. These include different low latency databases for serving. They may also include different BI platforms. They can also be treated as events that get consumed and processed into different ERP systems, sharing with partners in your supply chain network, and the list goes on. All right. I think in terms of the takeaways that we would like just to highlight here would be that, as Brandon talked in the beginning, Amazon Forecast, it's a purpose-built time series forecasting service. It has all the state-of-the-art time series models, a rich model library, and we continue to iterate and build on this. In fact, the cold start was just an update to the models released a couple weeks ago. And then Neeraj talked about how Taco Bell was able to instrument production workflows in a short time to market, and he also described the value prop that's provided his business and his business stakeholders. And then finally, I showed you an introduction to step functions as a way to orchestrate. First, with CloudFormation as a way to deploy, and then secondly, using step functions to orchestrate. And then finally here, if you'd like, this is the QR code that will lead you to our GitHub site that provides, essentially there's going to be a set of directions there to README. There's also a YAML file available that will deploy the CloudFormation, and you can customize that to your schema and your data. So you're welcome to take that. You could also do a web search on AWS Forecast samples GitHub as well. So you would actually do this at your own pace, but if you have any questions about this or need any support, please do reach out to your AWS account manager or your solution architects that you may be working with, and we're happy to help come to a conversation with you. And that's all I had. We've got some time, but I'd like to invite the colleagues up here, and we can take some Q&A with the remaining time.